Hello and welcome back. Today we're going to be working on making the AI control on the ceiling using the navigation code that we worked on last week. Now I do end up having to change up a little bit of the code, but it all works out. If you are unsure exactly what we're doing, you probably should watch the previous video, as the previous video kind of went over everything that we're going to be doing here. Today we're just going to be jumping straight into code and getting everything working, and then dealing with some bugs that end up cropping up and getting everything looking fairly convincing. Alright, so let's go ahead and get started on that. Alright, and before we get started, there was a couple changes to the basic enemy navigation agent, kind of corrections to last week's episode that I had to make in order to make it work. I didn't realize what was going on until I actually got everything else working and then realized that this was causing an issue. So the first change that I made was, instead of just setting the desired velocity to vector 3.0 in the isTargetReached function, I also want to go ahead and check to see if we're too far away from the current target position. Go ahead and set the desired velocity towards the target position. This will mean that if anything jostles the AI, or it just happens to drift away from the target location, it'll wander back to that location. Wherever you set as the target position, it'll continue to try and stay there. Then we also need to handle gravity. Now down here I was actually handling gravity in line with an if statement to check to see if we're not supposed to be on the floor. Then we go ahead and handle our gravity there, and if we are supposed to be on the floor, we go ahead and set the gravity to initial gravity. I broke that out into its own function down here just called handle gravity, and it takes a boolean that says waypoint on floor. And the reason why is because I need to call it right here, but I also need to call it up here with the last retrieved path waypoint. When we're not pathing anymore, we need to stick to the ceiling if we're on the ceiling, or stick to the floor if we're on the floor, and this kind of solves some issues that I was running into. Now down here in the get current normal, I also went ahead and changed up a couple things. Instead of just using the get next waypoint function, I go ahead and use the last retrieved path waypoint normal, and then if that's null, then I use the get next waypoint function. The reason for this was it just ended up forcing the path to continue, and it was making it so that the AI wasn't functioning as intended. And last but not least, there's a couple things down here in the set new target function. I went ahead and set the estimated duration as that estimated duration multiplied by 2. This just gives the AI a little bit more time to get to where it's going before it tries to repath. This fixes a lot of duplicate pathing. Then also, instead of generating the current up vector the way I was, which was creating a vector 3.1 and multiplying it by a random value between -1 and 1, I created this new vector 3 that has -1 to 1 on the x and z, and then +0 to 1 on the y. This just ends up with an up vector that's a whole lot more actually random, as opposed to just going up in the same angle every time. And I go ahead and use that right here and just normalize it. And then a minor little change down here, I was setting the last on ceiling to false right here. That's no longer necessary. Everything should be just fine. And that's pretty much it. So I'm going to save that and build it. Everything works fine, and we can move on to the rest of the code. Alright, so we're going to dive right into code here. We're going to be modifying the enemy AI controller, as there's not too much that needs to be modified. So let's go ahead and get started there. Now, first off, we're going to go ahead and delete this roller ball as a rigid body 3D, as our navigation agent is going to be the basic enemy navigation agent, which means it is also the rigid body. Now, there's a couple things down here that are going to need to change as a side effect of that. As you can see here, it's not getting the roller ball anymore for the linear velocity, so we can just pass in the navigation agent. Then right here on line 144, we're also going to need to change how we're setting the target, as if you remember, we're setting the target with this set new target function, and this will just be done via the NavigationAgent.setNewTarget, passing it global position. We're also going to be swapping out the get final position, as we no longer need a function for that. We can just use the target position. Then also in line 184, we're going to be using the set new target with the target override. And instead of navigation finish, we're going to be using isTargetReach. So we're going to go ahead and swap out all the rest that are those functions. Alright, and that looks like it's going to be it. Now there's a couple changes we need to do to the Limb.cs file as well. While the enemy AI controller was just a pretty easy switch, the Limb does have a couple new changes. We're going to first add 2 new variables for the grounded as well as the flying time offset. Flying time offset's just going to be making sure that the flailing motion that we're doing with our hands when we're in the air, as we do want to move them somewhat, it's going to be offsetting the current time so that way each limb flails slightly differently. Then grounded is going to be set to false, but we're going to be setting this to true anytime we're setting on the ground. We're just going to default to false. This way it defaults to flailing the limbs, and then as soon as it touches down on the ground, it goes ahead and snaps the limbs to the terrain. We're also going to move the currently traveled Boolean up here with the control. It just didn't make sense being right there. And we're also going to add a new Boolean for the last waypoint grounded. Now, what we're going to be doing with the limb, now that we have these variables, we can go ahead and get started, is anytime we're in the air, we want to flail the limbs a little bit. We're just going to move them in a sine-based motion on the forward and backwards and a cosine on the up and down. So that way the arms generally move in a round-based motion. So in order to do this, we do need to know if we're currently on the ground or not, and we also need a flying time offset, as that sine-based motion is going to be controlled by the limb placement controller. So we're going to be passing in this offset anytime we need a position to put the limb. So if we go down to the physics process, there's a couple changes we need to do. First off, we can go ahead and delete this debug draw point. And we're going to say, if we're not currently grounded, then we need to move towards the generate target flying point functions result, which we're going to make in just a second. And we're going to lerp to that so that we don't move instantly. We're going to use the blend speed multiplied by the delta. And if that's not the case, then we're going to do what we were doing originally with a minor addition. So I was actually about to say to do something where I check to see if we're not hitting the surface, and if we're not hitting the surface, then to flail. I actually realized afterwards that it genuinely looked worse if I did that. So I kind of just went back to this. It handles everything. If it's on the surface or not, it goes in and adjusts for all that. So we're just going to leave it right there and move on with the rest of the code. Now we're going to go ahead and skip all the way down here to the bottom, and we're going to create a new function for that generate target flying point. And all it's going to be returning is a function that we're going to create in the limb placement controller for get target limb flying position. We're going to be passing in this limb as well as that flying time offset that we created earlier. Now the flying time offset is actually going to be assigned by the limb placement controller whenever we go into the air. So we need to go ahead and create a function to do that. So we're going to create a new function for set limb grounded state, and it's going to be having a Boolean for whether we're grounded on the ground with that limb. And we're also going to have a float for the new flying offset. And so if we are currently grounded and the new Boolean says we're not grounded, then we need to go ahead and reset our current lerp value, our currently traveling, and set our flying time offset to the new flying offset. This just means that if we happen to no longer be grounded, we want to stop all movement that we're currently doing and update the flying time offset. And this will go ahead and do that. Then we just set our grounded to the new grounded. Now there's just a couple more changes we want to do to limb before we can move on to limb placement controller. First off, in the set IK targets, we're going to go ahead and say if we're not currently grounded, then we're going to do something slightly different with the hand. Else we're going to do the rest of this. And all this is going to do is mean that if we are currently grounded, we need to go ahead and get the normal of where our foot is supposed to be and place the hand or foot accordingly. And if we're not currently grounded, then we're going to go ahead and rotate the hand to be pointed at a position out away from the hand. So we're going to take the Limb IK container's global position and lerp it with the enemy body's global position. So that'll get a vector halfway between the IK target and the actual torso of the body. And then we're going to subtract it from the Limb IK container's global position, and that will get a vector pointed out away from the body. And then we're just going to add to it the Limb IK magnet offset. And all this will do is just point the hands kind of away from the body. This generally works all right, and it doesn't look too wonky like we had before with the hands pointed out at weird angles, and this will fix that. So moving on, we do have one function we do need to create. And this is going to be a function called placeFootHard, and it's going to be taking the limb position code and kind of override everything to just place the foot down onto the ground without actually firing off any velocity changes. And the reason why we want to do this is we want to be able to place the feet down right before a jump, and all of the limbs are going to have this function called on them about a quarter of a second before we actually jump, whenever we're needing to launch up onto the ceiling or what have you. So we're going to kind of be repurposing some other code. And so first off, we'll just get a target position. We'll use the normal target function called getTargetLimbPosition from the controller. Then we're going to get a Boolean to check to see if that's too far away from the target. And if so, we're just going to set the current target location to the getBoneGlobalPose origin, and we're going to set the hit surface to false. That means we're moving in midair, which will just generally make it flail. We're going to create a new curve, and we're going to do it exactly like we do normally. And we're going to set our current lerp value and our current traveling to 0 and true. And the reason why we're doing it in this function as opposed to just the normal initialize step or get initial curve or what have you is because we want to just make sure that no matter what, we are moving towards this location. So we don't want any if statements saying, hey, if we don't have a good curve, then don't move or what have you. We just want to force the hand. And that's going to be it for limb. Now moving on to limb placement controller, this one's going to be a little bit more dense. So let's start off up here with the jump velocity. We're going to create 2 new exports just below it with the launch velocity multiplier and the max launch velocity. Now this is going to be used to make sure that the AI stays within reasonable bounds, but be aware that the max launch velocity, it needs to be slightly higher than the total distance that the enemy AI controller is actually allowed to reach for a ceiling. Otherwise you may end up with it wanting to be on a ceiling but then just never being able to jump to that ceiling. And down at the bottom we're also going to create 2 new variables for the flight flail speed and the flight flail size. Now the flail size is just the radius of the rotation of the hands, and then the flail speed is the speed at which those limbs move. And this is going to get generally an alright result. Now, as a private variable, we do need the current flight time, and this is going to be added to the flying time offset of each of the limbs in order to make each one of them slightly offset from one another. And down at the bottom, we do need a grounded state, which is just whatever our last grounded state was, and then we also need a launch requested, a boolean. And this is going to make sure that we don't spam launch requests, and it's also going to make sure that we don't do anything that's going to break us out of a launch while we're preparing for a launch. While we're putting the limbs down, we don't want to try and repath them. Now in the ready function, we can go ahead and just get our last grounded state, and that's just going to be pulled from the enemy body.currentGrounded state. And in the physics process, we're going to go ahead and comment out this, as we're not going to be needing it. We're going to be kind of reworking all that bit. So in the first bit, we're going to be handling if the grounded state has changed, and in order to do that, we're just going to each step of the physics process check to see if the last grounded state does not equal the current grounded state. We're going to go ahead and reset our current flight time, so our flailing resets. That way the current flight time never loops and you never end up with flailing that just teleports. Next, we're going to check to see if the grounded state of the enemy body equals none. That means we are in the air. If so, for each one of the limbs, we're just going to set our limb grounded state, and we're going to create a new random number generator and randomize it, then just make a random number between 0 and 10. Now, this number doesn't really matter so long as it's different enough, and so I didn't actually make it a variable because really just between 0 and 10 is just good enough. However, if the current grounded state does not equal grounded state.none, then we need to go ahead and place all of the feet hard. So what this means is that whenever we land on the ground, we're going to go ahead and force all of the feet down so that it has a nice solid impact feel whenever the AI comes down to the ground. And we're also going to be setting the limb grounded state to true. Make sure that you set it to true before you place foot hard. I found that to be an issue that I didn't even realize it was going to be an issue. It just doesn't know that it should be on the ground. And then finally, we're just going to set the last grounded state equal to the current grounded state of the enemy body. I did not realize, but yeah. So we can go ahead and uncomment this. We are going to be actually using this, as this is pretty much one-to-one with what we want. And all we're going to be doing is saying if the last grounded state does not equal none, so we are on the ground, then go ahead and do everything you would normally be doing with the limbs. Alright, so just above kickoff velocity, we're going to be creating a new function that's going to be handling all launch requests from the basic enemy navigation agent, and this will be handled just via a signal tie-in. And we're first going to check to see if launch requested, then return. That means we already have a launch in queue. And if not, we're going to go ahead and set that to true, so that makes sure that no matter what, when we are launching, we only have one going at a time. Then, for every single limb, we're going to be using the place foot hard function so that way all the limbs go down before a launch. And since this is an async function, we can go ahead and use the await and the toSignal function, which is just going to take a scene tree timer's timeout function and kind of await it inside of a C# function. This is a resolution to the issue of awaiting signals in C# versus Godot script. I think this was actually added with the 4.1, or maybe it was 4.2. It's a very valuable function, and you should always try to use it in C# as it allows you to be very smart in the way you use functions, and async functions in particular. So we can just go ahead and use the toSignal create timer and use the timeout of that timer. And so now 0.25 seconds, so a quarter of a second will have passed. We can go ahead and get our next waypoint. So that'll be wherever we're jumping to. We can create a new vector that will be the requested velocity, but first we're just going to assign it to the waypoint position of the waypoint. Just going to add to it the vector 3.up multiplied by the enemy body's global position's distance to the new waypoint, multiplied by 0.5. And all this is going to do is make sure that there's a little bit of a kick up based off of the distance away from the target location. This is not going to be perfect, but it is going to make sure that no matter what, there is a little bit of an arc to the jump. And as a result, you do want to kind of aim up a little bit above the target based off the distance between you and the target. You could definitely put in some accurate velocity estimation here, but for the time being this works and it's very simple to implement. Now the requested velocity we're also going to set to itself minus the global position of the enemy body. That's just going to get a vector pointed towards it from the enemy body's global position. Then we're going to multiply that by the launcher velocity multiplier subtracted from the enemy body linear velocity, and that's going to get a delta between this desired velocity and the enemy body's linear velocity. All this is going to do is that to make sure no matter what, the velocity that we have here is going to be the velocity we want to change our linear velocity by. We're going to make a real quick check just to see if the length of it is greater than the max launch velocity, and if so, we're going to equal it to itself normalized multiplied by the max launch velocity. This is going to clamp the velocity by whatever we set the max launch velocity. Finally, we can go ahead and set the enemy body apply impulse, the requested velocity, and then we can also set the launching requested to equal to false. And that should be pretty much it for launch requested. Now we are going to change a couple things. We want to change the basis of the chest target here to vector3.up so that way whenever we're jumping around normally, we want to be jumping upwards so it'll force us against the ceiling when we're on the ceiling. Next up, we're going to be swapping out the target rotation here with a slightly different version. We're going to be using the get ground normal from the enemy body, and then we're going to say if it is vector3.up, go ahead and do what we were doing before, where we check to see if the last velocity.y is greater than 0.99, and if so, we just make it vector3.back, if not vector3.up, because this is just kind of the rotation that we want the body to be rotated by. And we go ahead and set the looking at function. Instead of using the up vector of the torso, we just use the up vector that we just constructed right here. This goes ahead and makes sure that if we are on the ceiling, we go ahead and rotate the body upside down so that it sticks to the ceiling properly. Now we can ignore update head position, but we do need to modify the get target limb position. We're going to go ahead and do something exactly like we did up there, where instead of using the chest target container global transform.basis.y, we're going to be using an up vector that we're constructing from the get ground normal. This is going to make sure that the hands are arcing based off of the ceiling or the wall or the floor based off where we're at. Down here, we're going to do the same thing with the side angle. Make sure to replace it with that up vector that we just constructed. As well as right here where we're setting the target position, we need to use the negative of the up multiplied by the target offset down so that way the hand positions that we're moving to are down in relative to the torso. So this would actually be up if you're on the ceiling. And last but not least, we can go ahead and return that up vector as the normal if we haven't hit a surface, so that way the hands will be rotated upside down if we're on the ceiling. Now, in addition to this function, we do need a different function for handling the flailing limbs. So we're going to go ahead and create a new function called get target limb flying position, and we're going to be passing in the target limb just like we did up here with the get target limb position, as well as the flight time offset, which we're going to be adding to that other timer. Speaking of which, I almost forgot to add this in. Just below the last grounded state up here in the physics process, we do need to actually add to that current flight time the flight flail speed multiplied by delta. This is going to go ahead and iterate through that whenever we're in the air. We're going to go ahead and put that inside of an else statement so it only does it when it's in the air. Alright, so we can go ahead and scroll back down here and get back to work. So first off, we're going to go ahead and create an up vector. This is all going to mirror this up here pretty closely, so we're going to get started with that. Then we're going to create a new vector3, which we're going to call target position. We're going to be adding to it the enemy body's linear velocity multiplied by the velocity accounting multiplier. Once again, also multiplied by the target limb equals left foot or right foot. We need to go ahead and multiply that by 0.1 instead of 1. Now, we do this just because we do want the limbs to be kind of out behind the body when it's flying through the air. And we don't multiply by -1 or anything crazy like that because we don't want to go backwards based off the velocity. We just want to be not accounting for the velocity quite as much with the feet. Next up, we can go ahead and check to see if the enemy body's linear velocity is greater than 0.5. Go ahead and set it to whatever the enemy body's linear velocity is for the last velocity, just like we did in the previous function. Then we're going to go ahead and add to it the last velocity multiplied by the body length multiplied by, if we're left foot or right foot, -1. So that way it moves the target position out in front of the body if it's an arm or out behind the body if it's a foot. We're going to go ahead and create our center point and our side angles, which we're going to be using to offset based off the shoulders and based off of where the bottoms of the feet should be. Next up, we're going to go ahead and equal the target position equal to the center point, adding to it the side angle multiplied by the shoulder body width divided by 2. So that's going to push it out the side. We're going to set our limb raycast positions to that location. Then we're going to go ahead and set our target position equal to the center point plus the side angle multiplied by the bottom body width. So that's where the hand should be or the foot should be at the end of the limb, minus the up vector multiplied by the flight flail size. So this is just going to offset it based off of the rotation of the circle motion that we're doing with the hands. That to just make sure that the hands don't end up way far away from the body. Now it's time to actually construct the flail offset. Now the flail offset is going to be using the mathf.sine of the current flight time plus the flight time offset for the y-axis, so that's the up and down, and then the cosine of that same for the z-axis, so that's going to be forward and backwards, multiplied by the flight flail size. And this is going to get a nice circular motion. Now we can add that to the hand target position using the global transform.basis multiplied by the flail offset, so that's going to put it into local space of the chest, so it'll be moving forward and backwards and up and down in relation to the torso. We can go ahead and look at that target position using the limb raycast, just like we do in the previous function. Then we can go ahead and force that raycast update. Now we can check to see if we've hit a surface, and if we have hit a surface equal the target position equal to the limb raycast.get collision point. That way, if we are flailing, we still want to kind of account for whether we're sticking through a wall or not. And regardless, we're going to go ahead and return that target position. So that's wherever the hand or the foot should be. And that's pretty much it for the limb placement controller. We can go over to the limb controller and make sure that we are getting that function back. So we've got the get target limb flying position, and we should be good to go. So let's go ahead and build that and hop into the editor and see if we need to set up anything. So first off, we can go ahead and set up the navigation agent. We can leave the current target equal to whatever it was in the scene. Save that. We can go over to the roller ball, and we've got a couple things we need to set here. All right, let's set this to 2 and that to 2, and let's set world collision to the first layer. That should work just fine. Let's go over to the limb placement controller. All right, let's set this to 0.12. I found that just looks a little bit better. We're going to set this to 15 and this to 3. And that should be pretty much it. Let's go ahead and save that. Make sure we only have one of them in scene and test it out. All right, so I got that sorted, and the bug actually laid in the navigation code that I had written last week. One line of code I had changed from the baseline edit ended up being all it was required to actually break the entire thing. So now it's working. As you can see, there's a lot of paths, and this is due to the way I'm regenerating paths as necessary. And as a result, there ends up being a lot of changes in the movement. Now, this isn't ideal, and it's certainly not perfect for performance, so something to be aware of going forward, something I probably ought to need to fix. But for the time being, this works just fine. And as you can see, you can go ahead and transition up onto the ceiling and down again and go all over the place. And he crawls around, and in a group especially, this just actually looks quite convincing. Now, mind you, the paths obviously we need to work on. And oh, I forgot that there's a trigger that actually spawns another one. But that'll be it for this week. Thank you all for watching. Next week, we're going to be going into making them actually damage the player. And then following that, we're going to go ahead and make them work with audio and get audio in the game in general. And we'll be wrapping up this entire series shortly thereafter. We're actually getting pretty close to being done. As always, thank you all for watching. I hope you all have a wonderful week. We'll see you all back here next week for the next tutorial.